Hi, we're moving on to our second section of our chapter 11 of our unit 7, which is significance tests for a difference in population means. Our learning targets for this section is to show the appropriate hypothesis, check the conditions, calculate the test statistic and the p-value, but now we're going to be working with two sample t-tests for a difference in means. So remember what we did back with the proportions. We're going to be doing it with the means. So our null is going to be our mu sub 1 minus our mu sub 2 is equal to the hypothesis value. And remember, a lot of the times they say that they are equal. So you do need to do a little bit of algebra to move the mu of 2 over, making it negative, and that's going to be equal to 0. So that way we can use that null hypothesis when we're doing the test statistic. So our conditions, just like we did before, remember we have to check the random, that the data's come from two independent random samples or from two groups in a randomized experiment. Our 10%, you do need to check for both samples, not just one. And then the large count, you do need to check for both as well. Just like we did before, if the populations are normal, then the sample will also be normal, or we need to do the central limit for both, that the sample size for both of them are greater than or equal to 30. If not, we are going to have to do either a dot plot, whatever graph to show that it is normal. So let's look at this problem here. It says the Wade Track Preserve in Georgia is an old growth forest of longleaf pines that has survived in relatively undisturbed state for hundreds of years. One question of interest to foresters who study the area is, how do the sizes of the trees in the northern and southern halves of the forest compare? To find out, researchers took a random sample of 30 trees from each half and measured the diameter breast height, which is dBH in centimeters. Here are the comparative box plots and numerical summaries of the data. So they're giving us the mean and the standard deviation of both the north and the south, and they're also giving us a box plot here. Foresters want to know whether the data provide convincing evidence of a difference in the mean dBH, which is the diameter breast height of trees in the northern and southern halves of the Wade Track Preserve at the 5% significance level. So we're going to go ahead and do our 4-step process. We're going to do the hypothesis first. So we're going to do our null hypothesis is our mu of north minus our mu of south is equal to 0. That means that there is no difference between them. And then the alternative is that there is a difference, so not equal to 0. We do need to go ahead and state our parameters here. So mu of north is equal to the true mean dBH in centimeters of all trees in the northern half of the forest, and mu of the south is equal to the true mean of dBH centimeters of all trees in the southern half of the forest. We're going to check our conditions now. So our random, they are independent random sample of 30 trees, each from the northern and southern halves of the forest. You do got to check for both. The 10% condition, 30 is less than 10% of all trees in the northern half of the forest, and 30 is less than 10% of all trees in the southern half of the forest. And notice that both of them are both greater than or equal to 30, even though they did give us, if you notice the box plot, we really don't need it because it is 30 is greater than or equal to 30 here. So our test statistic, it is our statistic. So this time we have the difference of the x bars minus our null, because remember there is no difference, so it would be 0, over the square root of the sample standard deviation squared over n sub 1 plus the sample standard deviation squared of the second one divided by the sample size of 2. Now, our degrees of freedom, you can use the technology, but remember, whatever the degrees of freedom that states in the technology is what you have to write down. If you're going to use table B, you find the degrees of freedom of each one, but you're going to pick the more conservative, so you're going to pick the smaller degrees of freedom. So calculating the standard test statistic, that's the formula we talked about. The best way to do this one is through technology, but you can go ahead and use table B here. And again, just like before, remember they do give us our general formula. We just need to make sure to piece it together from the section that we're going to be looking for when it talks about population of means. So using the calculator is really nice. So here, if our null is equal to 0 and our alternative is greater than 0 here, we're going to go to our stats, click on stat test, to sample t-test, and depending on the information that they give you, if they give you the data, you're going to have to input it in the spreadsheet. But notice here, I am giving you the stats. So I'm going to click on stats. I'm going to put the information for our first sample, the information for a second sample. Now our alternative, if I go back to this and I move the mus of 2 here, it's going to be mus of 1 is greater than mus of 2, and that's the one I'm going to pick. You pick the one that's based on your alternative. Once you press enter, make sure that the pooled always says no, and we'll talk about that a little bit more in class. But when you press enter, you will see all of this. You do need to write all of this on your sheet. So the t, the p-value, the degrees of freedom, all of this information needs to be on the on the due portion. So once we have that information, now we're going to go ahead and calculate the test statistic. Okay, if we found it with a calculator, if you're going to do it using table B, you put your statistic minus your null over your standard error. And you're going to make sure you're still going to draw this whether you have the calculator or you're doing it by hand. I do want to see this t distribution with the degrees of freedom here and where you're shading. So our p-value here, if we use the calculator, we got t to be negative 2.628. Our p-value would be 0.011 with a degrees of freedom of 55.73. What conclusion? Well, because the p-value of 0.011 is less than our alpha, which is 0.05, we reject the null. This data gives convincing evidence of a difference in the mean DBH of all trees in the northern and southern half of the forest. So the name of this inference is called a two-sample t-test for a difference in means. We are talking about two different samples. We're talking about a hypothesis test, so we're talking about tests, and it is the difference of means here. Now, does increasing the amount of calcium in an adult's diet reduce blood pressure? So researchers designed a randomized comparative experiment to find out. The subjects were 21 healthy adults who volunteered to take part in the experiment. They were randomly assigned to two groups. 10 of the subjects were received a calcium supplement, while the control group of 11 subjects received a placebo pill that looked identical to the calcium supplement. The experiment was double-blinded. The response variable is the decrease in systolic, top number, blood pressure for a subject after 12 weeks in millimeters of mercury. So it's that top number when they do your blood pressure. An increase appears as a negative number here, and this is the data. Now notice, this is an experiment, and also notice that a negative number shows an increase. So the first person right here that got a 7 actually decreased by 7. I know. Why would they put it like this, right? But we need to work with what they give us. So if we look at the next patient that got a -4, that meant that they got an increase in their blood pressure. So, does this data provide convincing evidence that a calcium supplement reduces blood pressure more than a placebo, on average for healthy adults like the ones in the study? So, we're going to do the 4-step process. So, we're going to state our hypothesis here, which is our null hypothesis is that mu of the C minus mu of P is equal to 0. So, notice here, our calcium and our placebo, there's no difference. And that our calcium minus our placebo is actually going to be greater than 0. This is going to be a one-sided because researchers want to know if calcium supplement reduces blood pressure more than a placebo. Okay, so that's one-sided. Of course, we're going to go ahead and define our parameters. Our mu of our calcium is a true mean decrease in systolic blood pressure for healthy adults like the ones in the study who take a calcium supplement. Mu of P, which is our placebo, is equal to the true mean decrease in systolic blood pressure for healthy adults like the ones in the study who take a placebo. Now, because they didn't state what significance level we're going to use, we're going to state the alpha is 0.05. Now we're going to go ahead and do the plan. So remember, this is a 2-sample t-test for difference of means because we're talking about the calcium and the placebo. They're independent there. So we're going to go ahead and check the random. 21 subjects were randomly assigned to the calcium or placebo treatment. Note that we do not have to check the 10% condition here because the subjects in the experiment were not sampled without replacement from a larger population. We do need to check always the large sample, and notice that 10 is actually less than 30 for both the calcium and the placebo, right? One is 10 is less than 30, the other one's 11, which is less than 30. Doesn't work out. But if we do the dot plots for each of those, well, it doesn't show a strong skewness and no outliers. So because it doesn't show it, all 3 conditions here were met. Now the do portion, again, I'm going to use my calculator to figure those values. Okay, so I'm going to find out what the X bar is for the calcium, the X bar of the P is the calcium, and I'm going to input that to get my test statistic. We can do that with the calculator as well. So our p-value, because we are talking about it being larger, I do want to see this curve where you tell me this is a t-distribution, degrees of freedom, and we're going to use the calculator here, so it's 15.59, and we're going to shade to the right. So our p-value here would be negative 0.0644. Now our conclude here, because the p-value of 0.0644 is greater than 0.05, we reject the null. The experiment does not provide convincing evidence that a calcium supplement reduces blood pressure more than a placebo on average for healthy adults like the ones in this study. Now, of course, we're going to go ahead and interpret what that p-value is. So assuming that the null, the mean of the calcium minus the mean of the placebo is equal to 0 is true, there is a 0.0644 probability of getting a difference, and you do need to state the order, calcium minus placebo, in mean blood pressure reduction for the 2 groups of 5.273 or greater just by chance involved in the random sampling. And that is our learning targets for this section. Great job.